Okay, let's continue. Estimation. Okay. You can estimate a population through sample. Okay. What if samples available is less than 30, meaning n is less than 30. Okay. What if the standard deviation is unknown? Okay, meaning it's not given. So z-score is not allowed. Okay, it's not allowed. Therefore, to solve the estimation, we need to use the distribution. Okay? T-distribution. Again, when do you need to use the T-distribution? Okay, you can use T-distribution if samples available is less than 30, if the standard deviation is unknown, meaning it's not given, so z-score is not allowed. So we're gonna use T-distribution. So T-distribution. So what is T-distribution? It is like z-distribution, continuous distribution. It's like z-distribution, bell-shaped and symmetrical. There is not one T-distribution, but rather a family of T-distribution. All T-distribution have a mean of 0, but their standard deviation differ according to their sample size. The T-distribution is more spread out and flatter at the center, the standard normal distribution. As the sample size increases, however, the T-distribution approaches the standard normal distribution. Okay? In short, the T value also depends on the degree of freedom denoted by V or DF. Okay, we use T distribution if the sample size is less than 30. Okay, we use T distribution if the sample size is less than 30 and if the standard deviation is not given. So we use T distribution. Okay. So what is the condition in T distribution? So first condition, under the T distribution, okay, if n is less than 30 and the standard deviation is unknown. So how do we write the confidence level in this particular condition? Okay. What is the confidence interval if n is less than 30 and the standard deviation of the population is unknown? So same concept. Okay, mu is greater than sample minus the margin of error, but less than sample plus the margin of error. The difference is that the margin of error. So what will be your margin of error? This time, it's not z. Instead, it should be t alpha over 2 multiplied by s over the square root of n. Why is it s? Why is it s? Because sigma is unknown, meaning the standard population, the standard deviation of the population is unknown. So the given is a sample standard deviation, okay, or the standard deviation of the sample or sample standard deviation. Okay, so T distribution, to come up with confidence interval, same concept. Okay, how to write the confidence interval, same. The only difference is the margin of error. So since we're talking about T distribution, so we're gonna use this formula, T alpha over 2 multiplied by S, that is your standard deviation of the sample or sample standard deviation over the square root of n. Okay, so how do we determine the T alpha over 2? Using the DF. DF is the degree of freedom, okay, which is n minus 1. Okay, degree of freedom, which is n minus 1. Okay, for example, example number 1. Suppose that a random sample of 10 students yield the following grades in mathematics. So these are the grades. So 90, 93, 85, 77, 88, 80, 78, 83, 95, 90. So 10 students. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So your sample size is less than 30. Okay. A. Construct a 95% confidence interval. So how do we construct that? First, solve for mean. So mean is equal to 90 plus 93 plus 85 plus 77 plus 88 plus 80 plus 78 plus 83 plus 95 plus 90 divided by the total number, which is 10. Okay, so how do you do that? Get a calculator. So 90 plus 93 plus 85 plus 77 plus 88 plus 80 plus 78 plus 83 plus 95 plus 90. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Divided by 10. So you do have 85.90. So that's the mean. Okay. So we need to construct a confidence interval. So the population mean is greater than the sample mean minus the margin of error, but less than the sample mean plus the margin of error. Okay. So we already have the mean. The only missing is the margin of error. So what is your margin of error? Since the sample size is less than 30, okay, and then the sigma or the standard deviation, it's not given. Okay, it's not given. So we're gonna use t this over 2 multiplied by s over the square root of n. But the problem, the standard deviation is not given. So how do we solve for the standard deviation? So s is equal to the square root of 90 minus 85.90 squared plus 93 minus 85.90 squared plus 85 minus 85.90 squared, so and then so forth up to 90 minus 85.90 squared divided by n minus 1. Okay, so upon having that one, your standard deviation will be, so your standard deviation is 6.30. Okay, so that's your standard deviation, 6.30. So n minus 1, that will be 9. Okay. So you have 6.30. But how do we determine the T alpha over 2? Okay, T alpha over 2. Of course, we need a T distribution table. So I will provide you the T distribution table. So this is the T distribution table. So according to the problem, we need to construct 95%. Okay, 95% Okay? So, these are 95 confidence interval. Okay? So, first, look for DF, degree of freedom. So, that will be n minus 1. So, what is your n? 10 minus 1, 9. So, to determine the T alpha over 2, use the T distribution table. Okay, so 95% confidence interval. Oh, here's the 95%. And then DF 9, degree of freedom 9. Degree of freedom 9. So get the intersection. So 9 and then 95%. So this is your T alpha over 2 is equal to 2.262. So that's your T alpha over 2, 2.62. Okay. Now you can now solve for E. So we have 2.262 multiplied by S, which is this one. Okay. Because sigma is not given. So solve for S. Sample standard deviation. Okay. For the T distribution, how do we know if we gonna use T distribution? If n is less than 30 and the standard deviation of the population, which is the sigma, it's not given. Okay? Kapag hindi given yung standard deviation and n is less than 30, so we're gonna use T distribution. Try to remember that. Okay? So going back. So we have 6.30 divided by the square root of 10. So therefore, your T value, your margin of error will be 4.51. So this is your margin of error, 4.51. Now, what is your interval? So mu, or the population mean, is greater than sample plus the margin of error. So mu is greater than, what is the sample mean? 85.90 minus 4.51, but less than 85.90 plus 4.51. So mu is greater than, get the calculator. So 85.90 minus 4.51, that is 81.39, but less than 85.90 plus 4.51, that will be 90.41. So therefore, so this is your interval. Okay, that is your confidence interval. So therefore, what is the interpretation? What is the interpretation? Therefore, the 95% confidence interval, okay, confidence interval for the true average grade, when we say average, or referring to the mean, okay, true mean grade or true average grade in mathematics is between 81.39 and 90.41. Okay, 81.39 and 90.41. Okay.